Let's go to page 259 and start with number 1. You have square root of 50 plus square root of 18 minus square root of 8. Right now you have all radicands are different, so you need to simplify each one of these. So you can go off to the side. So square root of 50, you can break down into square root of 25 and square root of 2. So get into the perfect square. So this would be 5 square root of 2. For 18, you can break down into square root of 9 and square root of 2. So this gives you 3 square root of 2. Okay, and the square root of 8, you can break it down into square root of 4, square root of 2. So this will give you 2 square root of 2. So go off to the side, simplify each one of these. Then after that, you can go and combine the like terms. So 5 plus 3 is 8, minus 2 give you 6. So it would be 6 square root of 2. Okay. And that's it. Now when you're adding the radicands, make sure you treat it as like a variable. Think of like a 5x plus 3x minus 2x. That will give you 6x. Okay, for number 3, we got square root of 27 minus square root of 75 plus square root of 48. Okay. So you can use the square root method, or you can use the ladder method. So like if you use the other method, you can break down to 3 and 9 and 3, 3, 3, 1. So 2 of these can come out, so this will give you 3 square root of 3. So you can use either method. But if you know your perfect square, it'd be a lot easier if you use the perfect square method. So break into 25 and 3, so this gives you 5 square root of 3. So you can use either method. Okay, 48. So if you know your perfect square, it really helps. Okay. Okay, and after that, you can go and combine the like terms. So it gives you 2 square root of 3. Okay, let's go to number 5. You have cube root of 81 plus cube root of 16 minus cube root of 24. Okay, so this one is not as obvious as these, so you can use the prime factorization. So you get 3, 27, 3, 9, 3, 3. So notice I keep going until I get 1, so I get all the numbers on the side. Because what happens if you stop over here, sometimes students will forget the number on the bottom. Okay, so this is the cube root, so I need to get 3 of them. So this would be 3 cube root of 3. So this 3 is this here, this 3 is this one here. Plus, okay, 16 break into 2, 8, 2, 4, 2, 2, 2, 1. So again, it's a cube root, so you need to get 3 of the radicand to make it into an integer. The leftover stays inside. Okay, do the 24. So you get 2, 12, 2, 6, 2, 3, 3, 1. Okay, so again, it's cube root, so this comes out. So it'd be 2 cube root of 3. Okay, so this is a different radicand, so you cannot do anything to these. So you only can combine this one and this one. So you're going to get cube root of 3 plus 2 cube root of 2. Okay, let's go to number 7. Okay, you got square root of 28 minus 2 square root of 98 plus square root of 63. Okay, so you can break down into perfect squares, so 4 times 7. Now 98 break into 49 and 2. This one break into 7 and 9. Okay, so you can break it down into parts and take out the perfect squares. So this get 2 square root of 7 minus, this is a 7 times 2 give you 14. And this would be a 3 square root of 7. Okay, so this is a different one, so don't do anything to that. So combine these two. So you get 5 square root of 7 minus 14 square root of 2. Okay. let's go to number 9. Now for number 9, don't waste time copy the problem exactly the same. So what you want to do is separate the top from the bottom. So you got square root of 2 over square root of 3 plus square root of 3 over square root of 2 plus 2 square root of 1 over square root of 24. Okay, so now what you want to do is you want to simplify each one of these first. So multiply. Now when you write this, try to spread out a little bit, so give you a little bit of space over here. So times it by square root of 3 over square root of 3, so that you will get square root of 6 over 3. This one you multiply by square root of 2 over square root of 2, so you get square root of 6 over 2. Okay, this one you get square root of 6 over 3. Okay, now this one over here, you go off to the side, so 24, break it down into 2, 12, 2, 6, 2, 3, 3. So this will come out, so you're going to get, now square root of 1 is just 1, right? So you get 2 over 2 square root of 6. And this will cancel out, comes 1. And I'm going to simplify this by multiply by square root of 6 over square root of 6. Okay, so I end up with square root of 6 over 3 plus square root of 6 over 2 plus square root of 6 over 6. Okay, so now to add fraction, you need to go ahead and get your common denominator. So your LCD equal to 6. So remember the 5 step how to add fractions, right? So that's your step 1. Okay, you don't have to write it 1, but I'm just writing it so you can follow. So step 1, get your LCD. Step 2, prepare your common denominator. So step 2 will give you denominator of 6. Step 3, you have to figure out what you need to multiply. So this one you need to multiply by 2. So you get 2 square root of 6. This one from here to here, you need to multiply by 3. So you get 3 square root of 6. From here, you don't do anything. So when you add all this together, you get 6 square root of 6 over 6. And they cancel out. So you end up with square root of 6. Okay, let's go to number 11. Okay, you have cube root of 4 plus 6 cube root of 1 over cube root of 2. Okay, so first let's go and simplify these. To simplify this, since it's a cube root, so you need to get 3 of them. So you only got 1, so you need to get 2 more. Okay, so it means you need to do the same on the top. So this will give you a 2, and on the top you get 6 cube root of 4. And this will cancel. So you end up with cube root of 4 plus 3 cube root of 4. So you end up with 4 cube root of 4. Okay. Okay, let's go to 13. You have square root of 15 times square root of 3 plus square root of 5 minus square root of 27. Okay, so first I'm going to simplify each part a little bit. So this one, instead of multiply, make into a big radicand, it's actually, you want to make it, break it down to small, into square root of 3, square root of 5. Times it by square root of 3 plus square root of 5 minus, this one you can go off to the side. Let's do it this way. Break into square root of 9 and square root of 7, square root of 9 and square root of 3, you get 3 square root of 3. Okay? Now the reason you break it down so that when you multiply, use your finger, so this, you multiply this one first, so this will give you a 3, so when you multiply this, it will give you 3 square root of 5. Now when you multiply by this will give you a 5, so it become 5 square root of 3. So when you break it down, it's easier to multiply. See that? This will give you 3 square root of 5. When you multiply this will give you 5 square root of 3. Okay, so this one is a different radicand, so cannot do anything to it. So you can combine these two. So you get 3 square root of 5 plus 2 square root of 3. Okay, let's go to 15. Okay, you have 3 square root of 12 plus 12 square root of 3 minus square root of 3 cubed. Okay, so this one you can simplify. So square root of 12 break into square root of 4 and square root of 3, so it becomes 2 square root of 3. Okay, so you're going to get 3 times 2 square root of 3. I can do one step at a time. So this is this. Okay, this one you don't have to do anything to it. This one, the cube, right? So you're going to get square root of 3, square root of 3, square root of 3. Okay, and then you're going to become 3 square root of 3. Okay, so this will give you 6 square root of 3. And now you can go and add. So this will give you 18 minus 3, give you 15 square root of 3. Okay. Okay, 17. Again, don't waste time, try to copy the problem exactly the same. So when you have a subtraction like that, okay, what you want to do is separate, undo the common denominator. So you have square root of 6 over square root of 2 minus square root of 18 over square root of 2. So this can cancel, so you end up with square root of 3. This one can cancel, so you get 1 and 9. So square root of 9 will give you 3, and so that's it. Okay, so I can separate the common denominator, make things a lot easier. Okay, let's go to number 19. You have cube root of 5 times cube root of 25 plus cube root of 7. Okay, now this is equal to, so if you look, this is equal to cube root of 5 times 5. Okay. So in this case, you got 3 of them. So when you multiply, this will give you a 5. When this one multiply, you don't have it now, so it'll be just cube root of 35. Okay, and that's it. Okay, let's go to number 21. You have the square root of p3r plus square root of pr cube. Okay, so this one you can take it out. Okay, so you can break down to this p squared pr. So get your perfect square out. Now you don't have to do this step. I'm doing this so easier for you to follow. This one you can take out the r squared, and you can have pr, right? Then after that, you can go ahead and make this into absolute value of p, right? Again, remember this. Okay, so remember you need to have absolute value for that, right? Plus absolute value of r times square root of pr. And then you can factor out the square root of pr. So square root of pr times absolute value of p plus absolute value of r. Okay. Okay, 23. So again, don't copy the problem exactly the same. Okay, don't waste time. Just go and separate the top from the bottom. So you have 4 square root of a over square root of 27. So again, when you have a square root of a fraction, separate the top from the bottom. Plus square root of 4a over 3 minus 2 square root of a over 12. Then after that, you want to simplify as much as you can. So this will give you 4 square root of a. Now square root of 27 will give you 3 square root of 3. Okay, again, if you don't see that, go up to the side, square root of 27, break into square root of 9, square root of 3, so you get 3 square root of 3. Right? Okay. This one, the 4 can come out, so you're going to get 2 square root of a over 3. This one you can cancel, so you're going to get square root of a over 6. Okay, now before you add anything, you need to go and take care of this square root of 3. Okay, so let's go and multiply by square root of 3 over square root of 3. So this will give you 4 square root of 3a over 9 oh wait, this one has a square root. Okay, we need to back up. Okay. Okay, redo. Okay, let's try it again. So you got 4 square root of a over square root of 27 plus square root of 4a over square root of 3. So again, when you separate the top and the bottom, remember the square root on the bottom. Okay, so you got 2 square root of a over square root of 12. Okay, let's simplify each one. So you got 4 square root of a over 3 square root of 3. Okay, this one you need to multiply by square root of 3 square root of 3. So, and the 4 can come out, so you get 2 by square root of 4 is 2. And you got 3a over 3. This is a minus. So you can go off to the side to do this. So this will equal to 2 square root of a. Now this will give you 4 square root of 3, square root of 4 square root of 3. And square root of 4 is 2, and 2 will cancel out. Okay, and so this one you end up with a square root of a over square root of 3, and multiply by square root of 3. So you're going to get square root of 3a over 3. Okay, so again, let's again go off to the side so it doesn't clog up the major steps. So you're going to get 3a over 3. So we have to take care of this one here, times by square root of 3. So you're going to get 4 square root of 3a over 9 plus 2 square root of 3a over 3 minus square root of 3a over 3. Okay, so we need to go and get the common denominator. So LCD is 9. Right? And so from here to here, you don't have to do anything. From here, you have to multiply by 3. So it gives you 6 square root of 3a. This one you have to multiply by 3. So it gives you 3 square root of 3a. So now you can add all this together. So 4 plus 6 is 10 minus 3 gives you 7. And that's it. Okay, let's go to 25. So you have a right triangle, and this is x, this is square root of 2, and this is 10. Okay, use Pythagorean Theorems, you use a squared plus b squared equal to c squared. So a squared plus b squared equal to c squared. Simplify, so you got 100 plus 2 equal to x squared. 102 equal to x squared. Take the square root. Normally you want to do plus or minus, but because this is a real object, so you don't need the minus. So just take the square root. So x will equal to square root of 102. And if you want to simplify, you can check. So divide by 2, you get 51. Divide by 3, you get 17, and that's it. So that's nothing you can simplify. So this is it. Okay, let's go to number 27. Number 27, you have this rectangular box. So you got the A, B, C, D, E. Okay, so in a rectangular side, it has a dimension of 2x, 3x, and 6x. Find in terms of x, the length of AC and AE. So you're looking for AC. You're looking for AE. So this one you have to use two Pythagorean theorem. So this is 2x, so this would be a 2x. Okay, so you use this triangle over here. So if you look at this triangle, the ACD, okay, so this is 2x, and this is 6x. Okay, use the Pythagorean theorem, so you're going to get 2x squared plus 6x squared equal to AC squared. Okay, and then go and work it out, so you got 4x squared plus 36x squared equal to AC squared. You add this together, so you got 40x squared equal to AC squared. Take the square root, so AC equal to square root of 40x squared. And again, you can break these things down. So square root of 40 can break into square root of 4 and 10. So it'd be 2 square root of 10. Okay, and the x can come out. So you're going to get 2x square root of 10. Okay. Normally you want to put a variable in the back. So AC equal to 2 square root of 10x. Okay, now to do AE, so now you know that this is 2 square root of 10x, right? So now you have to look at the next triangle. So now you have to look at this big triangle now. So you look at the ECA. And so this is 3x, right? Transfer it over. Transfer this over. And AC we just find, right? It's 2 square root of 10x. Okay, so to find AE, I can use your Pythagorean theorem. So you're going to get the A squared plus the B squared equal to AE squared. Okay, so can you square that? You get 9x squared plus, now this one we got it from here, right? See the square is actually this, right? So it's 40x squared equal to AE squared. You add this together, you get 49x squared equal to AE squared. So take the square root. So AE square root of that would be 7x. And that's it.